Okay, in this last lesson of Unit 2, we're going to talk more about angles, starting with vertical angles. And we're going to go ahead and do some drawing of illustrations in this lesson. Some of the previous lessons I've given you an illustration, but these are pretty easy to draw, and I think it would benefit all of you to draw them just to kind of reemphasize what these definitions mean. So vertical angles are angles that are opposite. It's any two angles that are opposite angles that appear anytime two lines intersect. And so the way you would illustrate this is you're just going to draw any two lines that intersect. And so I'll do one line and I'll do another line, and obviously my lines are not perfectly straight, but you'll get the drift. So anytime we have lines that intersect, we have four angles. I'm going to label these 1, 2, 3, 4 angles that are created, and the angles that are opposite of each other are what we call vertical angles, and they are actually congruent to each other. And so if we have two angles that are opposite because two lines have intersected, they are going to be congruent to each other. So in this visual, 1 and 3 would be congruent to each other, and 2 and 4 would be congruent to each other. And not all of our illustrations have to look exactly the same. So your lines might intersect more in this manner, and that's fine. So we would have a pair of vertical angles opposite of each other here, and then another pair of vertical angles opposite of each other here. Supplementary angles are any two angles who sum up to 90 and 180 degrees. And because it's 180 degrees, the two angles would obviously create a line beside each other. And so we're going to illustrate this. So let's say I have this first angle here, and say it's equal to 40 degrees. Then this other angle supplementary to it would be 140 degrees, because the two angles create a straight line and add up to 180 degrees. And anytime we're working with supplementary angles, so we could have one like this, if this angle is x, meaning, whatever it is, whether it's 105, whether it's 20, whatever it is, the other angle would be 180 minus that, because together they add up to 180. And so if you know one of the angles and I tell you they're supplementary, you're always going to do 180 minus the angle you know, because they have to sum up to 180 degrees. Complementary angles sum up to 90 degrees, which we know creates a right angle. And so we're going to have a visual here. And let's say this first angle here is 20 degrees. Since these two angles have to sum up to 90, this other angle would be 70 degrees, because 70 and 20 add up to 90 degrees. And those are called complementary angles, any two angles whose sum is 90. And so anytime you know one of the angles, so let's say we don't know this angle, and it's x, the other angle, whatever x is, would be 90 minus that. So let's just pretend that angle is 30. We'll keep it kind of clean numbers. Then you do 90 minus 30 to get the other angle. So if they're complementary, whatever angle you know, to get the other one, it's going to be 90 minus that angle, because that's what makes the two angles sum up to 90 degrees. So we've already talked about this theorem here. Vertical angles, angles that are across from each other, will always sum up. Vertical angles, angles that are across from each other, will always be congruent to each other. Then we talked about supplementary angles, angles that add up to 180, any two angles that add up to 180. And then complementary are any two angles that add up to 90 degrees. Now I'm going to move to a little activity that I think is fun that covers these three vocabulary words. And then we'll come back and focus on these theorems. Okay, so this is an assignment that I found online, and I think it's just a really fun better than just a typical worksheet for students to do in order to practice vertical angles, complementary, supplementary. So you would start here and say, okay, this angle pair is this vertical, supplementary, complementary, and they would say vertical. It's two angles opposite of each other. We know those angles are congruent, and so x is 80, and so they would follow downward this path here and come here. And then we would talk about this angle pair. that these two angles together make a straight line, making them supplementary. And so we would do 180 minus 120, which is 60, which would take us down this path. And then we see this angle pair, we can see that these two angles are complementary angles. They sum up to 90. So we would do 90 minus 64. And you know, you could either go this path, or downward. 90 minus 64 is 26, so we would come this way. This angle pair would be supplementary, makes a straight line, so we would do 180 minus 99. So 180 minus 99 is 81. So we would come upward here, and we have another vertical pair. So 78 and x are vertical. Vertical angles are congruent. Those are those angles opposite each other. The name is vertical. So x would be 78 and we'd move upward. And so I really like this. This came with two versions. And as a teacher, this is really easy to grade with this answer key. You can have the students, you know, mark their path, and you can see, you know, very easily if they've done it correctly. There's another version. So there's version B, and there's version B's answer key. So especially, you know, in the higher grades, it's always good to have multiple versions of an assignment. And so this would be something that I think would be a really good activity to cover vertical angles, supplementary, and complementary. So going back to the notes now, we're going to focus on a few more theorems. So the next theorem we're going to talk about is something we've already talked about in the last lesson, but I wanted to remind you of in this lesson because it's going to really help with the fourth theorem there in this list here. So we already know that the three angles in a triangle add up to 180 degrees. That's something we've already talked about multiple times. We've worked with that last lesson. We also know that a quadrilateral, all four angles in a quadrilateral sum up to 360. That's something we've already talked about. But having that here again is going to really help you with this next theorem. So the sum of the interior angles of any convex, that's important, we've already learned that word, polygon with n number of sides, so it could be 5 sides, 6 sides, 7 sides, 8 sides, is the number of sides minus 2 times 180 degrees. Then if you have a regular polygon, or if you'll recall that definition, regular polygons are equilateral and equiangular, meaning all the sides are exactly the same and all the angles are exactly the same. If it is regular, you could find one angle, a single interior angle, by taking that total degrees and dividing it by the number of angles. And I want to just make sure that, you know, everybody really understands these theorems. So I'm going to kind of draw you a visual here to reinforce this. So we know that the number of sides on a triangle is 3, and that these three angles sum up to 180 degrees. If we had a quadrilateral, so any four-sided polygon, we know that the number of sides here is 4, and that the total degrees here is 360. If we have a pentagon, we know here that the number of sides is 5, but we haven't really talked about how many degrees are in a pentagon. Or let's go ahead and draw, say, a hexagon where the number of sides is 6. And then, you know, we could go on to a heptagon, an octagon, etc. But here's something I want you to really think about and understand where this theorem comes from. If you have any quadrilateral and you create a diagonal connecting non-consecutive vertices, this is two triangles in it. If we are in a pentagon and we draw diagonals to these non-consecutive vertices, this one has 3 triangles in it. And if we have a hexagon, we could go here, and here, and here, and we end up with 4 triangles. So this is 180 here, this is 180 here. 180 and 180 is where we get the 360. Here, this is 180, this is 180, this is another 180. 180, 180, 180 would be the number of degrees in the pentagon. And then in the hexagon, we would have 180 in this triangle, 180 here, 180 here, 180 here. So it would be 180 times 4. So what you have to realize is where this theorem right here comes from is however many sides there are, like 5 sides or 6 sides, there are 2 less triangles if you connect those vertices. This here has 4 triangles. This here has 3 triangles. This here has 2 triangles. And notice from 4 to 2 is -2. From 3 to 5 is -2. From 6 to 4 is -2. So if you ever want to know how many degrees all of the angles inside a polygon add up to, you just count the number of sides, you take off 2, and you multiply that by 180 because the number of sides minus 2 is how many triangles fit inside that polygon. And every triangle has 180 degrees in it. So the number of sides minus 2 times 180 is how many degrees are inside whatever polygon you have. It could be 10-sided, 12-sided, whatever it is. So let's say that, we have a 9-sided polygon. To find how many degrees that 9-sided polygon adds up to, we would do 9 minus 2 times 180, because if it has 9 sides, it's going to have 7 triangles in it, so we would do 7 times 180. Now, that next theorem says if all the sides and all the angles are the same, which makes it regular, we could figure out what one of those angles is by taking the total number of degrees and dividing it by however many angles there are, and that would give me the measure of a single angle, but only if it is regular. So I'm going to go and pull up a little bit of a visual on some of these, and then we'll talk about this last theorem. Okay, so I love a good image search. Here, I'm liking this one down here. So if this right here, we have a pentagon. So 1, 2, 3, 4, 5 angles. To find what all 5 angles add up to, we would do 5 sides minus 2 times 180. But then to find one single angle, we would divide by n, which is 5, divide by 5, because all 5 of these angles are the same. Let's look at this little visual. Let's see what this looks like. It might be good, it might not, okay? So interior angles of regular polygons, so this is specifically regular. If it's a triangle, it's going to be 60, 60, and 60 because all 3 of them are the same and it has to sum up to 180. If it's a quadrilateral, it would have to be a square, 90, 90, 90, 90, because that's when all 4 angles are the same and it adds up to 360. Now, a pentagon adds up to 540 because remember we do 5 minus 2, which is 3. 3 times 180 is 540. But if we divide that 5 ways, that tells us that each of the 5 angles is 108. That's only on a regular polygon. On a hexagon, it adds up to, all 6 of these add up to 720 because a hexagon has 6 sides. And we do 6 minus 2 is 4. 4 times 180 is 720, but if we divide that by 6 angles, each of these 6 angles is 120. And you can continue on. You can do as many image searches as you need to, but that's those theorems. And you get a note card on your exam, and these are theorems that I would definitely write down on your note card to use for your exam. The last theorem and the last thing we'll talk about in this particular video is the sum of the exteriors. So no matter how many angles you have, no matter how many sides you have, the sum of the exterior angles, one at each vertex of a convex polygon, is always going to be 360 degrees. And I'm going to show you a visual for that as well. And that'll be the end of this video, and then we'll go on and do some example problems starting in the next video. But give me just a second to pull up this visual. So if we have a polygon, we have angles on the interior, and then we have angles on the exterior, and those are created, remember, when we draw out one of the sides, and we have this adjacent side and the extended side create an exterior angle. So if you have a polygon, all of the exteriors, you can see that these sides are extended, and we have 5 exterior angles, but they're always going to come together to make 360 degrees, which is a full circle. And if you want to know the measure of each one of those, you would take just 360 divided by 5, because there's 5 exterior angles. If it was a hexagon, you would take 360 divided by 6 to get each one of those. But the sum of however many exterior angles there are, depending on how many sides you have, will always sum up to 360 degrees.